Make sure you count your carbons, right? Because a lot of times people will mess this up by not including this carbon or accidentally adding another one, okay? So if your Grignard reagent has 1, 2, 3, 4, 5 carbons on it, you better be adding 5 carbons to this, okay? So at the end of the day, if you start with an aldehyde, you make a secondary alcohol, 1, 2, 3, 4, 5, with however many carbons added. Okay. And your Grignards or lithiums can be single bonded or double bonded, and that's fine. Okay. You're not really forming a triple bond with a metal on it. If you have a terminal acetylene, right, or terminal alkyne, you can deprotonate it and make it a nucleophile that way. Okay. And we've done that before. So what did I forget here? Well, the magnesium is just going to sort of go away at the end of the day.
What about Cl, chlorine?
It will be with the magnesium salt and get washed away with the aqueous workup. So what about the product that I mess up? Right? For the same reason as the hydride stuff, you start with a trigonal planar thing, the Grignard can come in from either face. Okay? So you get that racemic mixture. All right, so mechanism for this, I'll just use it from up here. The bond between the metal and the group that's being added goes and attacks the carbonyl carbon, kick up the electrons, nucleophilic addition style. Protonate the alkoxide, done.
Don't you put the wiggle line beforehand already?
You can, yeah.
Okay.
Most of the time, if I'm doing a mechanism problem, I'm going to give you one that's not chiral. But the mechanism is the same regardless of if you get a chiral center or not. Everybody okay with that? And so again, HCl is the workup, okay? And typically HCl is going to be aqueous anyway. So you can use water or acid. We will do a Grignard reaction where I think we use something like 3 molar HCl, which is just aqueous HCl. It's just a little better proton source. But if you put in just water, that's fine. Okay. All right. What do you suppose will happen if we treat the acid chloride with another organometallic reagent? So if you follow sort of the mechanism, okay, you're going to draw in the bond here. You're going to come in, kick up the electrons, just like always. O minus, Cl, pH. You got a leaving group on there, what happens?
It leaves.
Kick down, push it out. So now you got a ketone. So do ketones react with alkyl lithiums? They do, right? Okay, so I didn't show the example, I did the aldehyde instead, right? If you want an example of that, we can do. right? So ketone gives a tertiary alcohol instead of a secondary alcohol like the aldehyde. There's no chiral center there. It would be, yes, but there's no chiral center there. So can these guys react with ketones? Certainly, okay? So in this case, as this reaction progresses, right, you start to form more and more and more of this guy. At some point, you end up with more ketones than there are acid halides, right? As this starting material sort of reacts and goes away. So if you have one equivalent of the phenolithium, it too would run out at some point, right? And at the end of the day, you'd have some mixture of this and the next reaction of this, right? Which is tertiary alcohol. So ultimately, you can get two of those groups being added, okay? So if you added one equivalent of this, you would get some mixture of those two, okay? So all of this would react more than likely because it's probably more reactive due to sterics and other things than this guy. So you get this thing consumed, and then as that's occurring, you're going to be making some of the final product over here as well, okay? And of course, this happens mechanistically, just like we do before. O minus pH, pH, and then HOH. Gives the final product. So, we don't want mixtures at the end of the day, right? So make that two equivalents instead of one. Then you're forcing it to go all the way, right? So you throw in enough of that phenolithium, it's gonna push this thing all the way to the final alcohol. Do we need to worry about stereochemistry here?
It's not chiral.
No, because you're adding the same group twice, right? So in these cases, you don't have to worry about stereochem because you get two of the same thing added to that same carbon.
So if you're adding one equivalent, you're gonna have more of ketone than the alcohol?
It's hard to say.
Okay, but if you are adding two equivalents, then you're gonna have more alcohol.
Then you push it all the way,
Okay,
right?
okay.
So one equivalent forces it all to go here, second equivalent goes to here. And if you're ever doing this, you're probably adding in 10 equivalents of the alkyl lithium or something, right? Or 2.5, or enough excess to sort of push it through. What if we want to stop here? What's the other organometallic reagent that we know? What is it? No, organometallic reagent. That's a hydride source. The cuprate. So in these cases, you will most of the time see me write this as step 1, step 2, water or acid. Okay? From a mechanism standpoint, does the water come into play? Right, as we go to here? No, right? Okay, so the water in this case is purely a workup kind of thing, where at the end of the day, you're gonna wanna wash away all the cuprate or salt related stuff that has to do with the lithium and the copper, okay? So the thing that you have to realize here is that the cuprate looks like this, which in a little bit of an ironic kind of way, over there we used reagents that had multiple hydrides that would go fully, and then when we wanted to stop once, we have the thing that has one hydride. Here, the thing with one thing attached can add multiple times if you add more equivalents, where the thing with two of them will add only one, right? So I think that kind of gets a little confusing sometimes, but just remember that the cuprates are a little bit less reactive, and they're gonna only deliver that phenyl group once. So you take the pair of electrons between the R group and the metal, add in and kick up, O minus, pH, kick down, kick out, and we're done. Y'all getting sick of this mechanism yet? So, mechanisms in this chapter, very straightforward, right? You're either doing nucleophilic addition and stopping, or you're doing acyl substitution followed by nucleophilic addition, okay? So, keeping straight what reactions do what, and what reagents are sort of going all the way to the end, or stopping in the second one, or that part of it becomes a little bit sort of more to juggle. But in terms of the mechanisms, I mean, you've seen me draw the same thing like 8 times today already, right? Questions about any of that? So a couple things from a synthesis standpoint. I mentioned the other day that this is a good way to start to build your molecule by adding more and more carbons. So, what you should also realize is there's other, how to say this, there's other reactions that you know previously that are good substrates that will interact with the hydride sources or the organometallics. But just to sort of show simply, if we have RMG Br, okay, so that's whatever alkyl group that you want. If you want to add one carbon to this and have a functional group at the end that you can do stuff with, you're going to want to add formaldehyde. So if we take this and add formaldehyde followed by HCl, you ultimately are going to get a carbon and an oxygen added. Okay? So you'll end up with R OH. Okay? So if you're looking at a molecule, right, that you're trying to synthesize, right, and you're trying to figure out sort of what you want to do, if you have a carbon that needs to have added to it a carbon with an oxygen, this is the simplest version of that, right? Okay, so you add one carbon and that's where the alcohol is attached. If you change these from H's to R groups, right, then you can have other stuff attached here. But still, at the end of the day, you have carbon-oxygen, right? So if you look at it and you recognize you want to add carbon-oxygen or need to along the way, then the ketone aldehyde situation is where you want to be, okay? So contrary to this, if we add an epoxide, what are we adding?
2 carbons?
2 carbons. So here you're going to get things like that. So if you look at your thing and you're trying to add carbon-carbon where there's an alcohol, then this is your entity, right? And we can do this with sort of branched epoxides. I a lot of times don't do that because it makes it look a little more confusing. But if we put in a second alkyl